Invasive species affect a wide range of sectors, including agriculture and forestry. Regardless of which sector is studied, invasive species have four major consequences. First, because there are few or no natural controls, it is extremely difficult and expensive to manage invasive species once they have become established. Authors from a 2005 review of invasive species in the U.S. calculated that damages and losses from invasive species are estimated to be nearly $120 billion annually. Second, invasive species lead to increases in pesticide use. Take, for instance, European gypsy moth, which has been established in the eastern U.S. since 1868 and causes an estimated $30 million annually in control and lost revenue to the timber and agricultural industries. Several millions of acres have been treated with pesticides to slow the spread of this insect. Invasive species can also have significant effects on human health. A 2013 study showed that there was an increase in human deaths related to cardiovascular and respiratory illnesses in counties affected with emerald ash borer. Humans exercise less and have less overall well-being if they live in areas affected by emerald ash borer. Finally, invasive species are a leading cause for species extinction worldwide, second only to habitat destruction. Invasive forest pests exist across the U.S. Here is a map showing the distribution of over 450 exotic forest insect species. The Pacific Northwest has a moderate amount of exotic forest pests, while the Northeast U.S. has the highest distribution. Some of the pests that exist in the Northeast have not been established in the Pacific Northwest, such as gypsy moth and emerald ash borer, although there's a high likelihood that they will do so in the future. So, now that we learned what invasive species are and what some of the consequences are, what can we do about them? This graph is known as the invasive species curve. On the x-axis is time. On the y-axis is the area infested by an invasive species, or you can also think it in terms of control costs. In either case, as time goes on, area infested and control costs increase. There are three main strategies for managing invasive species. The first is prevention. Preventing an invasive species from being introduced is by far the most cost-effective with the least amount of area affected. The second best strategy is early detection and rapid response, commonly referred to as EDRR. If an invasive species gets past preventative measures, detecting it early while eradication is still possible can lead to successful management of new invasive pests. Unfortunately, some pests are very hard to control once they are established and reproducing. It is at this point that the public becomes aware of their presence. At this time, they are causing considerable damage and are too costly or impossible to eradicate. Then they must become part of the natural system, and integrated pest management, or IPM, must be employed. The Forest Health Unit at Oregon Department of Forestry has reviewed several state, national, and international databases and has identified over 100 invasive species that are either currently causing significant damage to Oregon's forests or those that are not present in our state but appear to be on the horizon. Many of these species have the potential to affect urban and community forests across the state. These lists are split between the top unwanted, or those that are not established in Oregon, and the most damaging, those that are already here. The lists comprise a mix of plant pathogens, forest insects, noxious weeds, and even one mammal, feral swine. Today we will cover two of these invasive forest pests, the emerald ash borer, which is not present in Oregon but it's looming, and cankers disease, which is currently affecting Oregon's urban and community forests. The first invasive forest species that we will cover today is emerald ash borer. This insect was first detected in Detroit, Michigan in 2002. Based on tree ring analysis, we know the invasion started in the mid-1990s. Despite monumental efforts for eradication and containment, it has spread to 32 states, expanding west as far as Colorado. Over 100 million ash trees have been killed by emerald ash borer. This insect attacks and kills true ash, deciduous trees in the genus Fraxinus. In North America, there are 16 native species of Fraxinus. All are at risk from EAB. Experiments in Ohio and Michigan revealed that our native Oregon ash, Fraxinus latifolia, is also highly susceptible to emerald ash borer. Many species of ash have been planted in communities across Oregon. Here is a table showing the most common ash in Oregon and their level of susceptibility to emerald ash borer. Green ash, white ash, as well as a couple of European species are all highly susceptible. One Asian species, Manchurian ash, is produced by Oregon nurseries. It has co-evolved with emerald ash borer and is rarely killed except when damaged or stressed. The cost of emerald ash borer has been tremendous. Over $1.7 billion in control measures and losses are attributed to this single insect. Most of the expenses have fallen on local governments and property owners. In this pie chart, over half the cost of emerald ash borer, or $850 million, has been saddled by local governments. Property value losses have totaled over $380 million. In the next couple slides, I will show an example of property value losses. Landowner costs for removing dead ash has totaled $350 million. The cost to the hardwood timber industry has been $60 million, and costs to the federal government have totaled $36 million. It is worth pointing out here that these numbers come from a 2011 review paper, so the costs are obviously higher than what is reported here. Overall, emerald ash borer has become the costliest invasive forest species in the U.S. So, how much will emerald ash borer cost Oregon communities? There have been some good tools developed to estimate costs of emerald ash borer. One of these is Purdue University's EAB Tree Cost Calculator. The link is posted here and in your resource guide. We can begin to see how these costs add up. Within Portland's online street tree inventory, there are approximately 72,000 public ash trees, or about 4.8% of the tree canopy. Using very conservative estimates of tree removal, about $290 per tree, and tree replacement, about $387 per tree, the total cost to remove and replace all public ash in the Portland street tree inventory would cost about $50 million. This estimate doesn't take into consideration ash trees that are not captured in the inventory, such as backyard ash trees and ash trees in parks and riparian areas. So the cost of removing and replacing dead ash trees in Portland will cost local governments and homeowners tens of millions of dollars. And all the ash mortality can happen very quickly, within 10 years or less. In these next two slides, you can see the effects of EAB on a street lined with ash trees. In this before picture, most of the mature trees lining this street in Ohio are susceptible to ash. This picture was taken in 2006, just as EAB was arriving to the area. The next picture will be the same street 3 years later. All of the mature ash trees on this Ohio street were attacked and killed by EAB. Here's where we can see the implications to property values. These homes lining the street were perhaps valued at $350,000 or $400,000. After EAB, these same homes are not valued at $350,000 or $400,000. The rapid loss of tree canopy in urban and residential areas has led to tremendous costs to landowners and to society. One can also begin to connect the dots to human health, increases in cardiovascular disease, depression, etc., with extensive tree losses in communities. Next, thousand cankers disease is our second invasive species we will cover today. This one is interesting because it kills black walnuts, which are exotic to Oregon, but have been planted as shade trees and as food crops starting over 150 years ago. The disease symptoms were first noticed in the U.S. in the Willamette Valley in the 1990s, but it wasn't until 2008 that a team of researchers identified the fungus responsible for killing black walnuts. It was later discovered that the disease and its insect vector, the walnut twig beetle, are both native to southwest U.S. and Mexico. Subsequent surveys revealed that it had quickly spread across the western U.S. to communities and farms where black walnut had been planted. The disease complex is now in Tennessee, the native range of eastern black walnut. The standing value of black walnut in the U.S. is valued at $539 billion. The disease kills healthy, well-watered black walnut within 2 to 6 years and is very hard to control, even if it's caught early. Other species of walnut are also vulnerable, including Oregon's only native species, the Northern California walnut, and another widely planted species, English walnut. Arizona walnut, which co-evolved with the disease and the twig beetle, is rarely killed. Northern California black walnut hybrids show variation in resistance to disease, as shown in this picture from Benton County. The tree on the left shows no symptoms, while a few hundred meters away, a different genetic hybrid shows significant crown dieback. If the bark from a dead branch is removed, one can observe the feeding galleries of the walnut twig beetle littered throughout every branch. The walnut twig beetle is tiny. Pictured above is the adult, which is about 1 millimeter long. In the middle picture are exit holes where beetles have completed development and adults have left the tree. Each one of the tiny holes was made by a single adult leaving the tree to find a mate. In the bottom picture is a branch where the outer bark has been removed to show cankers caused by the fungus, which is carried as spores by the beetle vector. A single canker would have no effect on the tree's health. However, as the tree gets attacked by more and more beetles, the cankers coalesce and the phloem layer is severed, cutting off supply of sugars from the leaves to the rest of the tree's tissues. The disease complex should really be called millions of cankers disease. Emerald ash borer, thousand cankers disease, and other invasive forest insects and diseases share some similarities that are worth pointing out. First, untreated firewood and other types of solid wood material, especially green wood or wood with bark intact, are known to harbor insects and microorganisms. There's a national campaign to educate the public on the dangers of moving firewood. In Oregon, it is against state law for commercial firewood producers to sell their product in Oregon unless it originated from Oregon, Idaho, and Washington, or the product has been heat treated to 140 degrees Fahrenheit for 60 minutes. Second, time is of the essence when detecting and reporting invasive species. In the next couple of slides and in your resource guide, I provide ways to educate yourself on emerging invasive species threats and how to report suspect invasive species using the state's online hotline. Third, proper sanitation and wood waste disposal is essential for eradication and containment efforts. Natural resource managers can actually spread things like thousand cankers disease and Dutch elm disease if their tools and instruments are not properly sanitized. Chipping infested wood material or storing it in a secure area before disposal is often part of a quarantine action, and city managers must start thinking of suitable locations in their jurisdictions, if they haven't done so already. Fourth, there are insecticide products on the market such as imamectin and benzoate that can provide single tree protection through stem injections or soil drenches. However, there are obvious considerations of using pesticides such as cost. It can cost between $300 and $500 to protect a single ash tree for 1 to 3 years, and other costs such as environmental and human health risks. For instance, because black walnut is considered a food crop, certain pesticide regulations do apply. On the last slide, I mentioned that education is one of the best tools available for early detection. The Oregon Forest Pest Detector Program is an excellent example of interagency cooperation where the goal is to train an army of first detectors who are able to notice key signs and symptoms of invasive forest pests. Since 2015, officials from these agencies have created the Oregon Forest Pest Detectors to train over 500 professionals on the basics of invasive species, emerald ash borer, Asian longhorn beetle, and others. The class is free to students, and students have an opportunity to obtain continuing education credits through the International Society of Arboriculture, Society of American Foresters, and the Oregon Department of Agriculture Pesticide Program. The program uses a combination of online learning modules, face-to-face classroom time, and demonstration field courses. Classes are currently being taught by OSU Extension this spring and fall. Check out the course schedule on the link provided in the resource guide. As I have pointed out, early detection is essential for a successful rapid response. The state has many different ongoing methods of survey and detection of invasive forest pests and diseases. Agencies such as the Oregon Department of Forestry and the Oregon Department of Agriculture routinely survey the state for emerald ash borer using purple panel traps, or for European and Asian gypsy moth using these green pheromone traps. Sentinel sites in key areas across the state, such as along transportation corridor, the Columbia River, are surveyed for newly arriving exotic wood borers, ambrosia beetles, and bark beetles. There have been dozens of new insect species documented in these surveys since the 1980s, most of which do not seem to be significant pests at this time. However, every year, the Oregon Department of Forestry, in cooperation with the U.S. Forest Service, conducts aerial surveys of all 28 million acres of forest in the state, across all ownerships. The results are printed in the annual Forest Health Highlights, which can be found on the ODF Forest Health link in your resource guide. Finally, agencies such as ODF employ entomologists and pathologists who respond to inquiries regarding tree health from the field. The state has an incredible system for the public and professionals to report any type of invasive species, including forest insects, diseases, weeds, aquatic species, and several others. This is an effort led by the Interagency Oregon Invasive Species Council and administered by Portland State University. Users can go to this website and within 60 seconds log a report of a suspect invasive species. No username, account, or special app is required. The website is mobile friendly and uses the GPS and camera of a mobile device to help log the report. Reports are sent to a variety of hotline managers from across the state representing several agencies. The hotline managers follow up with the report and publish the outcomes of each one to the public so that false negatives can be minimized. I encourage you to visit the website and see some of the reports. For people that are not comfortable making a report on a computer or smartphone, there's a toll-free number as an alternative, 1-866-INVADER. By using the online hotline or the toll-free number, you'll be contributing to vital early detection information to the experts best able to stop the spread of invasive species. At this moment, I'd like to talk about the Oregon Invasive Species Council, which is the state's coordinating body for invasive species efforts. As you can see from my examples, invasive species issues cut across business sectors and regulatory agencies. In 2001, the OISC was created to foster dialogue and improve communication regarding invasive species detection and control programs. There are 7 permanent member agencies on the Invasive Species Council, representing Oregon's Departments of Agriculture, Forestry, Environmental Quality, Fish and Wildlife, the Oregon Marine Board, Portland State University, and Oregon Sea Grant. In addition, there are 10 appointed members that serve 2-year terms. These members represent a broad range of local, tribal, and federal governments, as well as non-profits, private companies, and others. The mission of the OISC is to plan and lead a coordinated and comprehensive campaign to prevent or manage invasive species in the state. The OISC meets quarterly, and more information and a calendar of events can be found on the agency's website and social media pages. One of the OISC products is to publish a 10-year strategic plan and a 2-year action plan for invasive species efforts in our state. Objectives for the state are described in terms of prevention, early detection and rapid response, control and management, education and outreach, and coordination and leadership. The 2-year action plan recommends specific strategies for each management objective and outlines the responsible agencies. If you are a local government or state government official and you want to know which agency is in charge of which aspect of invasive species programs, whether that be developing quarantine laws or surveying forests or water bodies, this is your best resource. Finally, another recent product of the Oregon Invasive Species Council is the Emerald Ash Borer Readiness and Response Plan for Oregon. Beginning in January 2017, staff from Oregon Departments of Forestry and Agriculture, along with Oregon State University, City of Portland, the City of Corvallis, the U.S. Forest Service, and the USDA Animal and Plant Health Inspection Service, met 6 times to draft this plan. National and regional experts in emerald ash borer detection and control, as well as officials from neighboring states, were consulted during live video conferences. In January of 2018, over 45 agencies and every tribal nation in Oregon was invited to review and provide feedback on the draft plan through an advisory committee meeting. The plan and associated document have been uploaded to a website, www.oregoneab.info. The plan will be updated as the science of emerald ash borer detection and control is advanced. In short, the plan aims to prepare Oregon communities for the arrival of emerald ash borer. It defines the roles of stakeholders and agencies involved. It provides a risk map for the state as well as the best methods of detection. The plan goes through what will happen if there's a positive detection of EAB in the state, what types of funding are available, and the available control options. Okay, well, thank you for listening.